It's a pretty good showing for the last talk of the day. I want to respect the fact that the only thing between you all and a happy hour is us. So we'll try and keep it as concise, but also as helpful as possible. So thank you for your last little vestiges of attention that you have today. But I'm really excited for this talk, mostly because I learned so much in the process of preparing this talk with Dan, that a lot of us are familiar with preparing data pipelines for different use cases, but I always think it's very interesting learning from people who cannot fail, right? Like, I want to learn how to drive from an F1 driver. I want Michael Phelps to teach me how to swim. I don't know if he would ever do that. And in this situation, Dan is working in a really high-pressure situation, which we call the DEFCON 1 situation, okay? It's not the Cold War. It is not nuclear war. It is not info security, but it is a payments pipeline at a payments company, and these things cannot go down. But just by way of a quick introduction, Dan is a senior analytics engineer at SpotOn, where he builds and maintains end-to-end data warehouse infra. And previously, he came from an operational management position at Veo and Postmates. What I want to call about Dan is that he is an extremely fast swimmer, biker, and runner. He was at the front of the pack yesterday, and also a very good friend.
I'm no Michael Phelps.
But I mean, compared to us, you might be. It's really been a pleasure working with Dan over the course of the past couple of years. I'm Kevin Hu, the CEO and co-founder of a data observability platform called Metaplane. You'll hear a tasteful amount about Metaplane later. All I want to say is that we help you maintain trust in the data that powers your business.
All right. So with that, SpotOn, what do we do? SpotOn, we're helping restaurants and small businesses compete and win with flexible payment and software technology. If you've ever worked in a restaurant, you might have used our point-of-sale systems. If you've ever been a manager at a restaurant, you might have used our labor solutions. We have seamless point-of-sale integrated into those solutions, and every SpotOn tool is designed to help local businesses increase their profits, create better experiences for their customers and their employees. So the part that Kevin alluded to that I'm going to talk about is payments. So as you can imagine, there's a ton of complexity that tags along with that. So at SpotOn, we have to both make sure that the transactions go through when you, as a customer, tap a card at a merchant's terminal, and also that the merchants get paid on time. So the problem that we have to solve for today is building those stable pipelines that enables our team to facilitate money movement and enable monitoring of said pipelines to make sure that we can sleep at night so that we don't have to worry about it before we have to worry about it.
But before we dive into any acronyms, we want to educate everyone, and I knew absolutely nothing about payments, about the 30,000-foot view or 9,000-meter view, as Dan puts it, view of payments. So, like, we've all walked into a coffee shop and beeped our phones on a terminal. But what exactly happens behind the scenes?
Well, the answer is a lot. So as we all tap to pay, we send an authorization request up through our processors and card networks, all the way to our cards issuing banks. Hopefully, they send a thumbs up back so we can enjoy our delicious mud water.
So this takes place over the course of?
Seconds.
Seconds?
Yes.
But it's not like Venmo, right? Where like I pay you money and you get it instantly. Like, how do you merchants get paid?
Well, here's what's happening behind the scenes. So to pay out the merchants, it's very similar to the way that the transaction flow worked, but instead of for each transaction, a merchant will batch out at the end of the day, sending information on all daily transactions up through their issuing banks and the Fed, with ultimately an ACH payment being sent to that bank, to their bank account. And so this ACH payment piece is the portion we're going to be examining a little bit further today. So SpotOn used to rely on our processor to initiate this movement via instructions from our point-of-sale systems. But SpotOn has transitioned into more of a payments facilitator or a PayFac, in that we are now responsible for executing on this money movement. So in the old world, we would rely on that processor to pay out our merchants, which was TSYS. So we currently receive files detailing transactions and batches from TSYS that we parse and ingest via a custom Python pipeline used in internal reconciliation and reporting. But now that SpotOn is aiming to become that PayFac, we have to monitor for these files, plus make them readily available and correct so that our team can actually execute this ACH to pay out our merchants. So in order to do so, we're transitioning from utilizing TSYS to WorldPay, or FIS, which lets us, one, save money as a company by not having to pay out that middleman to execute these ACH. Two, create a faster scheduling for this ACH so we can get the money into those hands of those merchants faster. And then three, relevant to us in the room, we can rethink our legacy ETL pipeline and bring it into the modern data stack.
So custom pipelines, let's talk about them. What's the deal?
Thought you'd never ask. So here's our current flow. We run those specific Python apps to facilitate the gathering and parsing of information from these files that were sent, loading from SFTP servers to S3 for our raw storage, parsing those files into RDS, and then moving them into Snowflake with Fivetran. From a top-down standpoint, it's a very simple system that we attempted to make more modern with a myriad of problems. Oh, crap.
Oh, shit. Control, delete.
So the big issue is that they would just silently fail out of the blue, when no one really truly understanding why, which led to a day of debugging and solving for little issues just to slightly improve upon that stability. This cannot fail in our new world. Costs had also started to rise, and so with paying for EC2, RDS, Fivetran monthly active records to Snowflake for our end users to consume, to ultimately having to pay for compute and storage there as well. We really wanted to keep costs down so that we could use the budget to fuel other more fun initiatives. And then also, as we're starting to think about broader patterns to really bring the data into a more centralized location at SpotOn, we had other teams creating similar pipelines to this, each with their own issues. So we saw this as a challenge to create a unified data ingestion pattern for third-party sources for SpotOn to use. And then lastly, the root problem that I'm sure a lot of us can relate to here is that we lost a lot of original context of why these decisions were made for this custom pipeline. The original developers actually no longer around. And why these decisions were made used to be all in their heads, and now they're nowhere. So let me just let it be known, documentation is a gift to our future selves.
Amen. So without further ado, enter the modern data stack.
All right, so here's another diagram of what our solution looks like, including dbt in practice. So shown with our old method along with our new pipeline, with a few things similar. So we're still bringing the files in from the SFTP and loading them to raw to S3, but then we use SQS to trigger a load to Snowflake via Snowpipe, making it available almost immediately. From there, we actually utilize dbt to parse and maintain the definitions for each of these different file types.
And as they've developed this pipeline, in order to help maintain some of that sanity, SpotOn has Metaplane peppered throughout the data warehouse, from the loading raw tables to the source tables, all the way down to the business-facing final tables. And what Metaplane is doing is that we're soaking up and monitoring all of the metadata. Some of it is foundational, like row count and freshest metadata, but there's also granular data quality metrics that are being monitored.
Yeah, so with Metaplane silently watching over our warehouse, what does it actually look like to an end user at SpotOn when something happens out of the ordinary?
Well, first we have to define what exactly ordinary looks like. Now, sometimes ordinary is like the sawtooth pattern when it comes to how often a pipeline is being refreshed. What that means is that every hour we're looking at when was the last time that this table was being loaded. It looks like a sawtooth. Maybe it updates every 24 hours. Oftentimes, it's much more complicated. And what Metaplane does is we take all of the historical metadata, we try and backfill as much of it as possible based on your query history, and start establishing, okay, what is normal based on historical trends, seasonality, and also annotations based on feedback from the business. And when something goes awry, so for example, the number of rows is increasing in a customer's table, it's reasonable, then you get a gigantic jump. What we'll do is we'll send you a Slack alert. Dan is maybe too familiar with those Slack alerts, saying, okay, this is the problem, this is the downstream impact, So for example, is nothing using this table? Probably not worth your time. Or are there many dashboards that are actively used that are impacted by this issue? And also, what are potential upstream root causes? Once you have that, you can give feedback, close it out, or leave it open so that you can deal with it another time. So anyways, we've been talking a lot about metadata and architecture, but something that blew my mind as we were preparing this talk was when Dan showed me the actual data that he's dealing with. So what does the data actually look like?
So enter the Enhanced Merchant Activity File, or EMAF for short. As you see, it's just a text file. A single positionally delimited file with separate subfiles for merchants and records associated with authorizations and settlements at individual and transaction and summary levels to help with reconciliation. Surprised I did that in one breath.
Yeah, that was wow. Swimmer.
So as you can see, this isn't your normal CSV, JSON, or even, heaven forbid, XML. So what does this actually look like parsing this in practice? Well, seen here, this is an example of a subsection for merchant authorization credit subfile identified from the header to the trailer records. So within these subfiles, we have different record type identifiers that tell us what is involved in the transaction in each row. And then also to add to our nesting doll of a file, a transaction can have multiple record types. But inside of each of these record types, identifiers, they behave similarly to CSVs, but instead of separated by commas, they're delimited by position. So my guess, and honestly hope, is that most people in this room have never had to worry about these, and you won't have to in the future. But now that we have a better understanding of what these files actually are that we're working with, we can take the spec sheet over here on the left and get the details of these attributes associated with each record type and create DBT models based on this specification, substring being a powerful function in this case. When new versions of this spec sheet are released, our team or other developers at SpotOn can check out our documentation, and then they can modify or add relevant DBT models for these changes. We like to really have an open environment for this collaboration. And so while this EMAF is WorldPay specific, our old world with TSYS files is a very similar format. And it consisted of a plethora of those Python and Bash scripts that would take multiple hours to parse through a single file. And while they're not entirely huge, we're still encroaching the hundreds of millions of records each month. So imagine having to spend the time to reparse multiple files for each day if you were needing to backfill just because of a parsing error. So now that we've created this more modular system based on SQL, we can parse through one of these files in a matter of seconds, which is just an inconceivable amount of performance increase. So in reality, there's a little over 100 different record types inside of the EMAF with a one-to-one relationship of these DBT models. So to get a more zoomed out view into this file parsing system, and actually how they flow into that final usable object, we can take a look at dbt Cloud's Explore view. So something that should look rather familiar to most of you, I hope. This visualization is fantastic to help us understand what it takes to parse out these record types, create linkages with some window functions for separate subfiles, and ultimately create a cleansed transaction entity for us to send off to our payments operations teams to get our merchants paid. But expanding on dbt Cloud's Explore view, we're also curious on how people are actually using this inside of SpotOn. So for paying out those merchants and also that reconciliation reporting internally. So this is where Metaplane also has a few lineage tricks up their sleeves. Kevin, tell us a little bit about how we can actually understand how people at SpotOn are really using these objects.
I mean, tricks is putting it generously. I would say, spending hundreds of hours looking at the, the Liquor v4 API is another way of putting it. But whether you use dbt Cloud or Core, we sync the manifest to get, among other things, the model-to-model lineage and model-to-exposure lineage that you have in dbt. And this is sort of the ground truth. And as we know, dbt is expanding and making it more and more granular. What Metaplane is doing is overlaying on top column-to-column lineage that we infer from your query history, downstream lineage that goes beyond Tableau into Looker, Metabase that you're using, Mode, and also to reverse ETL tools, and also upstream through ETL tools to your transactional database. So you can get a real end-to-end view of how data is flowing beyond the warehouse.
Yeah. Love not just having Tableau and having some Metabase. We're very meta-oriented at SpotOn. But this view, it just really helps me understand that if I make a change, what business units I need to talk to ensure that nothing is going to break inside of those downstream assets. I just really love seeing the wild and wacky ways that business users are utilizing our data. On that topic, I would also love to dive more into Metaplane's data insights. So this gives us a view into the costs associated with these queries, not just costs to build the models.
Right. By this point, you wouldn't be surprised to learn that Metaplane stands for metadata plane. It's a place that you put all of your metadata. And that metadata not only describes data quality and lineage, which we know is important, but also spend, performance, and usage. At least in our view of the world, when we deliver a data product to the business, there's a contract, whether or not, it could be implicit, it could be explicit, that data does this thing and meets this use case with some satisfactory level of quality, yes, but also performance and cost. And so what we're showing here are the queries and credits associated with that cleansed authorization table broken down by user.
But there's so many other slices. For example, this portion of Metaplane helps me answer questions like, what are our most used tables that could really use some optimization? What are the least used tables that I could actually deprecate? What are the longest running queries by user? And I really like that last one because that's how I can actually teach people at SpotOn how to write better SQL or judge them based on their SQL techniques.
Dan called it a board of shame at some point.
Yeah.
Oh, you said it, not me. But these data insights, this category of questions, we categorize it under, data professionals would love the answer and can get the answer because the data exists, but that you all are probably too busy to ask these kinds of questions and to answer them. So what we'll do is we'll surface it for you so that you can think of it like insights about your data rather than insights in your data. So it's almost as if you had a data analyst analyzing your data for you. And OK, excuse me for 2 slides. I will have to switch into commercial mode. You all knew what was happening when you stepped into a sponsored talk. But I'll only talk about the 2 pieces that are highly relevant to DBT that I personally use as a DBT user too. So you're merging in a PR, right? What happens? Well, this is our CI/CD integration such that every time you merge in a DBT PR, we'll give you 2 comments. One of them is a test preview report. So if you were to merge in this code, what is the actual effect on the data, right? By running a diff between your staging PR and your staging schema and your prod schema. The second is what we call an impact report, saying these are the downstream assets that will be impacted by merging in your PR. So we'll trace the column level lineage and say, OK, X Looker dashboards or Y Snowflake tables. And so the goal is that 1, you can ship faster without breaking things. 2, you reduce the downstream risk of developing your models. And 3, you can perform root cause analysis faster. Second thing is, OK, after you merge in changes, how do you know that your DBT jobs are still performing as you would like or not degrading? So we have historical trend analysis very similar to the data quality monitoring, but applied to DBT job durations so that you can see when the runtime of your jobs or also your models are taking longer than usual. And this can be an early indicator of some issues. Some of them might be good issues like increased data volume, or there could be resource bottlenecks or inefficient queries. So that now it's not really a surprise when a DBT job might take longer than expected, but when there is a surprise, we'll include all of the error messages, the downstream consequences, enriched based on the lineage, and also, it's not shown here, the model-to-model breakdown so you can understand those cost and performance bottlenecks. And with that, commercial over. Thank you, everyone. Back to Dan to wrap it up.
All right, so let me bring you back out of the metaverse, and I can wrap us up with where we are today with the pain points on what we've really solved for. First off, fragility. So we're not hosting our own architecture anymore, so we don't really have to worry as much as for our systems failing now. We're in the modern data stack. And also having Metaplane layered on top really helps us understand if and when loading data malfunctions, not only errors, but also anomaly detection as well. Secondly, kind of in that context realm, starting from scratch really allowed us to create a documentation-first mindset, really just making it easier for SpotOn, other people at SpotOn to actually contribute to this project. We can move faster without breaking things. No longer having to reparse those individual files if data types change, maintaining item potency in our modeling. Metaplane also gave us confidence for any changes that we wouldn't affect users downstream of those modeling efforts. Thirdly, dollar bills. Obviously we're still paying for Snowflake, but that really just outweighs the hosting costs that we're spending with AWS on compute and storage, and also Fivetran for those monthly active records. Those really increase quickly. And then lastly, inside of reproducibility, now that we have an understanding of these best practices that we really want to maintain for this pipeline, we can easily scale out to other teams that are looking to adopt the same practice to actually be confident in their data loading methods.
So thank you, everyone, for your last little bit of attention for today. We would love to be in touch. Feel free to add us on LinkedIn or send us an email. And we have some time for questions, if anyone has any. Yes.
I'm curious, do you ever encounter errors in your source data? And how do you handle that in critical situations?
Oh, shoot. Me personally, I encounter those issues all the time. I'm sure you want to hear that.
Do we still want this?
Did everyone hear the question? Like, do we ever encounter data quality issues in source data?
I don't know if you.
Yeah, my question is just, do you encounter source data quality issues in those positional delimited files? And how do you handle something like that when the outcome is someone not getting paid or the wrong person getting paid or things like that?
Yeah, so we do have that inside of that anomaly detection that I was talking about. So also having like those hard set Snowflake functions so that those queries will actually error out before they actually hit production. We can have it set so that it either alerts on load or also as these models are incrementally building. You might have noticed we utilize Lambda views inside of there as well, so kind of taking incremental one step further. So we can kind of have more real-time data, but also table performance. So we can kind of like understand and continuously test as we're building those Lambda views. I'm doing all the work here. You guys are really seeing me run.
I was just wondering, is it possible for daily transaction data to be restated or be erroneous so it gets canceled out maybe at the end of the day? If so, how do you flow these changes through your model? And do you have a way to like backfill this data?
Yeah. So one thing is, if you were here for the DBT core talk right before this, they're talking about micro batching. So you kind of like taking that incremental modeling a little bit further. So you can utilize that approach. But if you're talking coming from the source systems, that does make it a little bit harder because then we'd really have to get kind of more banking and transactional things available. So it is possible. It is more of a pain, kind of getting into those more manual workflows.
So I might have missed this, but is there a separate like transactional system that's also ingesting these files and driving the like time-sensitive ACH things? Or are you using Snowflake in your critical path?
Yeah.
So it's not just BI and reporting. You're actually like spitting out Nacha files and moving the money back based on running DBT on a hard deadline, right?
Correct. Yeah. So we ingest those files from FIS nowadays, but we don't actually handle that money movement. As I was saying, we do hand it off to another team who is the Nacha files.
Okay.
But yeah, so if we don't have it, they don't have it, essentially.
Yeah, so it's like this quite of like applying a tool for data observability that's designed for the slightly statelier like BI reporting. Oh, the CEO wants to see the reports first thing in the morning, sure. But it's, yeah, I guess I'm just curious, maybe from like vendor and like like supporting those kind of use cases has to be kind of a stretch from traditional like enterprise BI, right?
It is, yeah, and I'm not gonna lie that sometimes it makes me sweat a little bit too. I would say especially when we work with financial services companies, the stakes are much, much higher. And there's a range, right, going from like BI to marketing automations, which also should not go down, right? Send out the wrong email, and to machine learning, like to AI, I gotta incant it once. I would say that's probably more of a progression, right? And as we go up that progression, maybe the frequency of the checks is higher, the amount of interaction with the APIs, so that we make sure that we have the right monitoring architecture is much higher, but thankfully the same models can be used across the different use cases.
Yeah, no, that's really cool. I think applying the things we've learned from data engineering to these like traditional enterprise batch processing use cases is so exciting. So thank you.
Yeah. And I guess to add on top of that, with the old file parsing, it would go down all the time. We wouldn't really understand. So kind of layering it in and having Metaplane essentially as our shepherd in the warehouse for our little sheep tables, really just helps me not sweat and truly be able to sleep at night, so I don't have to be on call 24/7.
I feel your pain.
Run, Kevin, run.
So you mentioned you switched from Fivetran to Snowpipe, right? So is it just about the money or any pros, cons? And how often do you run these incremental models? Because the Snowpipe, it must be like real time you are planning, right?
Mm-hmm.
So.
Yeah, so Fivetran is the old way. Obviously, for those of you that have used Fivetran, it gets pretty pricey pretty quickly. So utilizing that the SQS into the Snowpipes gave us that more real time, even though it is, we're receiving these files once a day. So they truly are just batch. We have a good understanding of when they'll land, but not actually when they do. It's usually typically within a 15 to 30 minute time window. So we run dbt incrementally during that inside that time window. But then, as I was saying, that Lambda view, kind of not an entirely supported materialization inside of dbt, but having a table of everything that we've had incrementally building and then a view on top of it makes it available almost real time. Hopefully. I need a whiteboard. So you have a physical table. So if you're thinking about it from a DBT perspective, it's a couple different model specifications. So you have your source, and then you have an incremental model, which is built and fully materialized as a table inside of your warehouse. Then you have the same exact specification set up as a view, and then you can union those together. So if you think about it, you're querying the source system for a timestamp essentially that has not hit that physical table. So every time you rebuild that physical materialized table, you either have something inside of the Lambda or inside of the Lambda view specifying your view with a subquery saying where it's not inside that table, or you have a physically materialized variable set for that view. They're pretty cool. Look them up. There's inside of the DBT experimental features, there's a good portion on them. Anybody else? No? Well, if that's it.
Thank you, everyone.
Yeah.